Hello, good morning everyone. How are we all? I hope you all had a nice weekend. Today we are moving on and we're going to start the new topic of volcanic activity and look at the formation of volcanoes today. So in our previous 2 weeks, you'll know that we studied the structure of the earth and plate tectonics. So we looked at all the structure of the earth, the different layers of our earth and what each layer consists of, and we also looked at plate tectonics. We looked at how the earth's surface is divided up into large plates that move, and the reason they move is because of the convection currents that happen in the mantle, and they move in different directions. And today we're going to build upon that knowledge and we're going to look at how volcanic activity and the formation of volcanoes. So we have 2 learning intentions for today, and our first one is to describe the formation of a volcanic mountain at colliding plate boundaries. Okay, so by the end of today's class, we're going to be able to describe how volcanic mountains form using our keywords. Our second learning intention for today is to draw and label a diagram of a volcanic mountain. Okay, so by the end of the class today, each one of you is going to be able to draw your own diagram of a volcanic mountain and label it with all our keywords. However, first things first, the first thing I want you to do today is a little recap exercise. So we're going to have a little recap on last week's work, and I want you to name the 3 different plate boundaries that form on the Earth's surface, and name the feature or the natural disaster that occur at each plate boundary. Okay, so in your copy you can label, your title is going to be volcanic activity. Okay, so volcanic activity is your title for today, and then your subtitles recap. Then what you're going to do is you're name the 3 plate boundaries and either name a natural disaster or a landform that forms at each plate boundary. And I'm going to leave this little map here to help you with that, okay? So you can use that map to help you out on that one. You have about 3 minutes to complete that. Okay, so at this point in the class, I'll take the role, so the kids will be working away doing their startup activity. This is kind of a settle down activity, but also recaps on last week's work and lets me know where their learning is at. So it's checking in for learning. I just need to make sure that they understand plate tectonics, because if they don't understand plate tectonics well enough, there's no point in me moving on with volcanic activity, because it's going to be hard for them to understand as well. So by completing this activity, I'm both settling the class down and I'm making sure I'm just checking for prior knowledge before I move on. So what happens is the kids have a question and they stick their hand up and we'll answer the question. I don't answer the question for them. I usually try to give them hints and prompts so they come to the answer themselves, or if they're really stuck, I might ask somebody from beside them or another person in the class, can they help them out and help them with the answer rather than me handing them their answer, because they won't learn that way. And then what we could do is I'll go on in the class and I'll correct the recap activity. How I correct the recap activity is I have lollipop sticks with all their names on them. So I'll pull out a lollipop stick, and it could be Johnny, and I'll ask Johnny to give me the name of a plate boundary that he has wrote down, and then either a landform or the natural disaster that he described that happened at that plate boundary, and I'll do that a couple of times around the room. That will be fine then, and then what I'll do is I'll actually ask a few temperature check questions as well, just to make sure that make sure that they know the structure of the earth as well. Now I checked for this last week, but I just want to reinforce it one more time to make sure they know it. So again, I pull out my lollipop stick, I'll see whose name is on it, and I'll adapt my question based on whose name is on the stick. And it's a mixed ability classroom, so not everyone is at the same kind of standard. So if it's a student that I think is well capable, I'll ask them a higher order question, but if it's a student that I think might struggle a little bit, I'll ask them a lower order question. So I pick the name of the student, I ask the question, I give them a few seconds to think about the answer to the question, and then I'll ask the person I pulled out in the lollipop stick, and I'll do about 4 or 5 of them based on the structure of the earth, just to make sure they have that right then. The next thing I do is I just quickly recap with them to make sure they know the plate boundaries, and I'm going to do that on the board here now with them. Okay, so now we just corrected them, and we're going to go back over them one more time. So we have 3 types of plate boundaries, and our first one is sliding plates. And as we just said, at sliding plate boundaries, the 2 plates are sliding past each other. Okay, so all this tension's building up, and what happens eventually is an earthquake might form. Okay, so they form earthquakes. Now we have another name on sliding plate boundaries, and that is passive. They become passive plates. And the reason we call them passive plate boundaries is because they're not constructing and they're not destructing new land. So we call them passive. Okay, they're passive. The next one we're going to look at is separating plates. Okay, so this is where the 2 plates pull apart from each other. Here's one plate, Here's my other plate, and they pull apart from each other. They pull apart, creating a crack in the Earth's surface, and magma can come up through the crack in that Earth's surface. These form mid-ocean ridges, as we just discussed. These are also known as constructive plate boundaries. Constructive plate boundaries, okay? The reason they're called constructive plate boundaries is because they're constructing new land, okay? So as the plates pull apart, the magma rises to the surface of the Earth. It's then called lava. It hardens the little flies to create new land, so they're constructing new land. Therefore, they're constructive plate boundaries. The last one we have then is colliding plates, and this is the one we're going to be focusing on today. And colliding plates, when they collide, okay, so if I have an oceanic plate, this is my oceanic plate and this is my continental plate. My oceanic plate tends to be much heavier than my continental one, so it sinks down into the mantle of the Earth. As it sinks down into the mantle of the Earth, it's melted and it's being destructed, so we also call them destructive plates, and they form volcano. They form volcanoes. Okay, so this is the one we are going to be focusing on today. Okay, so this is the main one we focus on today. But one more activity I want you to do before we move on to the formation and how volcanoes form. I want you to, in your copy, you're going to label it volcanoes or volcano. And volcanoes, what am I doing? Sorry, volcanoes. And what I want you to do is I want you to, when you hear the word volcano, I want you to write down all the keywords that come to your mind. So give me all the words you can think of that are to associate with a volcano. So write them all down in a list in your copy, and we're going to discuss them in 2 minutes' time. So at this point in the class, the kids are having a chance to show me their knowledge of volcanoes. So it's a brand new topic, so the kids love to show their knowledge or the prior knowledge of what they know about something before we ever started. So what I do is I give them a chance to do that by giving me the keywords. So give me all the keywords they can. And on the left hand side of my whiteboard always is a section called keywords. And it's there for every class. So any keywords we come across, they go into this left hand side section of the board. So after the 2 minutes, I go around the room and I get all the keywords from the students and I put them on the left hand side of the board and we discuss each one. I then add to it. So any words the kids didn't have, I added to it and explained to them what each one of them were, and told them we'd come across them again throughout the lesson. So that they already had prior knowledge of some of the keywords before I started the explanation, and now I'm going to go into the explanation on how volcanoes form at colliding plate boundaries. Okay, so now we're going to look at the formation of volcanoes at colliding plate boundaries. Okay, so give me 1 second till I change my pen. Okay, formation of volcanic mountains. Okay, now the first thing we need to remember is our structure of the Earth. Okay, so just very quickly, you'll have seen this diagram before. So this is a little section as if I went into the Earth and I pulled out a section of it and how it's split up into its different sections. So we have the crust, the mantle, and the core. Now you'll remember from our study on the structure of the Earth that the crust is made of solid rock, and our mantle is much hotter than the crust, and it's made up of magma, which is molten or semi-molten rock, which means it's melted rock. Okay, so the crust, the mantle, and the core. I just need you to remember that for the day. Don't forget them. Keep them in your mind as we go through this diagram now. Okay, so the formation of volcanic mountains at colliding plate boundaries. So we've got our 2 plates. Okay, so I'm going to draw my oceanic plate in blue. Okay, so here's my oceanic plate, and I'm going to draw my continental plate in green. Okay, that's just to help you remember though. So this is my continental plate. Continental plate. Okay, and this here is my oceanic plate, and we can see here that my oceanic plate is subducting. Okay, so it's subducting, it's sinking, subducting into the mantle of the Earth. Okay, so this down here is my mantle. I'm going to label it the mantle now. This here is my mantle of the Earth. Okay, So when my oceanic plate, this is my oceanic plate, this hand's my oceanic plate, this hand's my continental plate. When the two of them collide, my oceanic plate is much heavier than my continental plate. So what happens is it sinks down into the mantle of the earth. Okay, so the crust of the earth now sinks down into it because it's much heavier. As it sinks down into the mantle of the earth, we know that the mantle is very hot, so that crust, that hard solid rock, begins to melt and it forms new magma. Now this magma can often form what we call a magma chamber. Okay, so this is my magma chamber here. It's a big bubble of magma in the mantle. Okay, the magma chamber. And as that plate further subducts and subducts and subducts, so as it sinks and it sinks and it sinks, it's melting more and more, creating more and more magma. Okay, so this is my magma chamber. This magma chamber becomes under great pressure. Okay, so all this pressure is building up and it's building up and it's building up, when this pressure eventually has to go somewhere. So what happens is the magma then erupts out through the crust of the earth in what we are going to call a vent. Okay, so this is called a vent. Where the magma erupts out through the crust of the earth, it's called a vent. When this magma erupts out through the crust of the earth, okay, it flows all over the crust just like this, and it hardens and it solidifies and hardens, and it forms a new crust on the earth's surface. Okay, so it's a new crust now. So magma erupts out through the vent, out through the crust in what we know as a vent. When magma reaches the earth's surface, we actually call it lava. Okay, and it flows over the crust of the earth and it hardens to form a new crust. This happens over and over again. Okay, it just keeps happening for millions and millions of years until what's built up is called a volcanic cone. Okay, and this here is my volcanic cone. Okay, volcanic cone. So over millions and millions of years, we have eruption after eruption after eruption after eruption, and each time it erupts, the magma pushed out through the crust of the earth in what is called a vent. When it reaches the surface of the earth, it's then called lava. It flows over the edges, it solidifies, it hardens to create new crust, and this builds up on top of each other years upon years to form new crust, which eventually forms a volcanic cone. The top of my volcanic cone is called my crater. Okay, so oceanic plate sinks, it subducts, it melts into my mantle, forming a magma chamber. The magma chamber becomes under great pressure. More pressure, more pressure, more pressure. It erupts out through the crust of the earth and the vent. It flows over the edges, hardens, creates new crust. This happens for millions and millions of years to form a volcanic cone. Okay. So the next thing we're going to get to do today is you're going to create an explanation for a volcanic or formation of a volcanic mountain. Okay, so you can see there's 6 statements here on the board for you. What I want you to do is to take out your hardback, and in your hardback you're going to rewrite these sentences in the correct order. Okay, so you're going to take each of these sentences, you're going to rewrite them in the correct order to create an explanation of how a volcanic mountain might form. Okay, so these statements and sentences are all jumbled up, they're not in the correct order, so you're going to rearrange the sentences by writing them out in your hardback to create the explanation for a volcanic mountain. You have 5 minutes to do that now. Okay, so at this stage you should have them all written out in your hardback, and we're just going to go through the sequence now. Okay, so the first one is when 2 plates collide, the heavier oceanic plate sinks into the mantle and melts. Okay, so the heavier oceanic plate sinks into the mantle and melts. As the plate melts, it forms a magma chamber. Okay, so we know that the plate was made of solid rock, so as it sinks into the mantle of the earth, it melts and forms a magma chamber. Great pressure causes the magma to rise to the surface in an eruption. It comes to the surface through a vent. Okay, so the vent, where it erupts out through the crust of the earth, is called the vent. Okay, there you go. Magma cools and hardens at the surface. This is called lava. Layers of lava and ash build up around the vent. Okay, so you can see on my diagram here that layers of the lava and ash are building up around the vent. A cone-shaped mountain is formed with a crater. Okay, and the crater is the very top of my mountain, so here would be my crater. That happens over millions and millions and millions of years, so it doesn't happen as a fast process. It's a very slow process. Okay, what I want you to do now is look over your own work, make sure you got them in the right order, and what we're going to do now is if you got it in the right order, we can put a big tick on our first learning intention to say we have completed it.